I'm joined today by photonics industry pioneer and veteran Jean-Michel Pelaprat to shine a light on the laser industry and dive into this essential and high growth market segment. Jean-Michel is a co-founder of New York Stock Exchange listed laser pioneer Nibiru and non-executive director of Australian laser manufacturer BluGlass Limited. He has over 30 years experience establishing, commercializing and scaling photonics and semiconductor businesses, and is co-founder and director of Nibiru, a US-based company recognized as a pioneer and industry leader in blue laser systems for the industrial, 3D printing and display sectors. Before founding Nibiru, Jean-Michel held numerous leadership positions in high-growth photonics businesses, including president and CEO of Vitran, a fiber optics capital equipment company supplying optical communications, fiber lasers, medical devices, sensing and aerospace applications. He was VP and General Manager of Coherent, managing the diode pump business unit and the semiconductor group. Over several years, he grew both businesses by over 4 times and substantially increased profitability. Jean-Michel, thank you for joining me today.
Thank you very much.
Jean-Michel, before we get into discussing laser technologies and their incredible markets, can you first tell us what is a laser?
A laser converts electrical power, essentially electrons, into optical power, which is photons, in high power laser beams, which are coherent laser beams. Coherent meaning that all the photons, all the light inside, is at the same frequency and are all in phase. Unlike LEDs, which are non-coherent laser sources, and therefore emits in a very large angle, a little bit like a light bulb, if you like. Lasers are highly focused, and that's a trademark essentially of the lasers. So the coherent aspect of the lasers provide 2 key features. Number one is not only it provides highly focused beam, but that high focus beam can stay for long distances. In fact, you can actually send laser beam to the moon and look at that. So highly focused for long distance. And the second aspect is that lasers are monochromatic, meaning they're generating light in the very small portion of a spectrum, either in the blue, or in the visible, or the infrared, but very narrow line width. Those 2 aspects of lasers make them highly demandable for many applications in the industry, science, and medical.
Jean-Michel, lasers and their applications are possibly not something that Australian investors would think about very often. However, lasers underpin all leading-edge industries and technology capabilities around the world. Can you give us more of an understanding of the impact and importance of lasers and what roles they play in technology and the world?
So lasers are an essential and ubiquitous technology. They are used into many applications. That goes from material processing to defense, to aerospace, to medical applications, to biotech, and to high technology manufacturing and packaging. In fact, lasers are underpinning the major trend in the world, such as the electrification of the world, in particular blue lasers, the digital globalization and consumer electronics, and the sustainability. In fact, blue lasers enable highly performance processes which make the overall process very green. So I can understand that the average Australian investor may not be aware about all the aspects of the lasers, but in fact, lasers are essential and critical in our day-to-day life.
There are 2 very different segments of the laser industry, the invisible and visible segments. Can you explain the difference and why this is important?
Of course. So there are indeed 2 segments. The traditional segment is the invisible, which is in fact the near-infrared wavelength, okay, just about 1 micron and above. And this is a traditional lasers that have been used in key markets such as telecommunications, material processing, and modern manufacturing, but also a number of applications in aerospace and also in medical applications. But there's been a new market, essentially in the visible, that has been driven by gallium nitride technology that has been coming for the past few years, that is the fastest growing segments within the laser market and provide superior, in fact, quite superior advantages compared to the infrared. The value of the blue lasers reside essentially in two aspects. Number one is the absorption of blue light in many materials, but particularly in metals, is much higher than it is in infrared, the incumbent lasers. For instance, in copper, which is used in many applications, right, in e-mobility and battery and so on and so forth, the absorption is 14 times better than it is in infrared. Gold is 66 times. Aluminum is about 3 to 4 times, depending on the alloy. So you can see this is not, we're not talking about 10, 20%. We're talking at a factor 10, a factor 50, a factor 60. That's tremendously. The second aspect of blue lasers compared to infrared is they can make much tighter focused beams. So the intensity or the power density, if you want, is much higher. The combination of those two things enables a quantum step into many applications. For instance, in manufacturing, you're able to go faster by speeds increase of 3 times or even 10 times with higher quality products. Or welding, for instance, or 3D printing, and highly sustainable, much more efficient processes. So this is, again, a quantum steps into the industry. It is very similar into the medical application, aerospace, or biotechnologies.
Jean-Michel, given their application importance and versatility, can you tell us about the size of the market?
Well, the overall laser market is expected to be around $25 billion in 2025. And as I mentioned, the segments, or the visible segments, which is driven by the gallium nitride market, as is in a going fast pace, is expected to be about 10% or 2.5 billion, also in 2025.
Jean-Michel, who are the consumers of these sorts of lasers? Who buys these laser systems?
So the end users or the consumers are not different, in fact, to the infrared lasers. They are original equipment manufacturers, or OEMs. They are system integrators that serve all the market segments I mentioned a bit earlier, and of course the end users. So we're talking about, for instance, the automotive market, automotive manufacturers, and their tiers level that are supplying to them. Same in the defense, but also system or end users in the medical market or the other markets I mentioned them.
So while investors may not know many of the world's leading laser companies, your end customers are a who's who of high tech and consumer tech today.
That's right.
Jean-Michel, given the enormous market opportunity and disruptiveness of visible lasers, what does the competitive landscape look like? Is the market highly fragmented like the semiconductor industry?
Actually, it is the opposite of the semiconductor industry. The gallium nitride semiconductor lasers is not very fragmented. Let me just say that the supply chain, going from the making the chips to the complete laser system that goes to the end user, right? To the end user, I would say there are two segments of that. There is what I call the low end in terms of manufacturing, which is people making the device and the low level integration. And then there's the other one, which are the laser manufacturers or the laser system manufacturers. This is sort of the two ends of the supply chain. On the low end, which is where BluGlass is participating, it's really a handful of manufacturers. And the two key manufacturers are really are also making LEDs and are essentially focusing on what I would say selected wavelength, a small mix of selected wavelength and high volume, highly commoditized product. And there's a high demand, actually, for customers about selected different wavelength, different packages, customization, which is really where actually BluGlass play a large role into. So that's the first part of the market. On the high end, which is Nuburu, which I also know reasonably well, on the laser and laser manufacturers, they're very similar. There is actually about a handful of suppliers worldwide. And the differentiation from one to the other is how they integrate the blue lasers into their system, laser and laser system, to preserve, I would say, the focusability, the brightness of the laser, and to be very efficient. And this is where there's differentiation at the way they integrate the blue lasers inside their system.
Jean-Michel, you've had a long and successful career in the industry, which has seen incredible innovation and change over the past 3 decades. What have been some of the biggest disruptors you've seen in the industry, and what do you think will be the next big catalyst?
I have been indeed around for some time. You can see with my my white hairs here. But I would say that I would focus on 3 of them. The first one is in the 1990s, I witnessed essentially the transformation of communication from copper to fiber optics. And it was a tremendous change, quantum step, to what we know today as essentially digital communications. Okay. The second one, also in the 1990s, is the shift from traditional lamp systems or lasers into diode pump solid state that enable the penetration of lasers into the manufacturing world, essentially the modern manufacturing using lasers. And then the third one is in the early 2000s, where fiber lasers, new lasers, fiber lasers, reinforced the penetration, and it really expanded the penetration of lasers into the manufacturing sector, enabling for the very first time using a laser 24/7. That was a revolution. And it is interesting to see that in all those three cases, the technology that helped to do that is semiconductor. So hopefully the fourth one we're witnessing today is the blue laser gallium nitride.
And Jean-Michel, to finish up, can you tell us why blue laser will be the next quantum leap?
That's a very good question, Paul. Let me answer that in a simple way. I think you've already got from me that the quantum leap in manufacturing is enormous. If you look at the simple number, we're not talking about a small increase. We're talking about 10x increase, whether it's in quality, speed, and so on. And that's an enormous quantum step. That's really what blue provides, essentially. In addition to this, blue enables a number of new applications that were not accessible or available in the past. We're talking about drastic improvement in, let's say, quantum computing, quantum sensing, and many applications in the blue. But quite frankly, the more exciting, and I can say that after 40 years in the industry, is the applications we don't know. If something of the past has told us is that we always discover new applications. Some are small, but some are very big. So I can't wait to see those.
Jean-Michel, this has been an interesting and informative discussion. Thank you so much for your time today.
Thank you very much for having me.